The biggest mistake buyers make is prioritizing fold speed. A Brompton takes 5 seconds longer than a Dahon, but that penalty buys you 43% less volumetric bulk. Folding bikes exist on a strict efficiency frontier defined by 3 variables: ride quality, folded volume, and fold time. The triangle fold, used by Brompton, optimizes for minimum volume through a 3-axis collapse, while the midfold, used by Tern and Dahon, prioritizes speed and stiffness using a single central hinge vector. Let's look at the volumetric reality because dimensions on a spec sheet can be misleading. A typical 20-inch mid-fold bike occupies roughly 150 liters of space, whereas a 16-inch triangle folder compresses to just 85 liters. This 43% reduction is the critical threshold that determines if your bike fits under a standard train seat or requires a dedicated luggage rack. The main engineering vulnerability in folding bikes is the central hinge, which endures high torsional stress during pedaling. To test a potential buy, apply the lateral load test. Hold the brakes and push the pedal hard at the 3 o'clock position. Any visible deflection at the main hinge indicates poor tolerance machining or insufficient latch tension. A common myth is that 16-inch wheels are inherently slow due to size, but speed is actually a function of gearing physics. To match a standard road bike, small wheels require a significantly larger chainring to normalize the gear inches. A 54-tooth chainring on a 16-inch wheel achieves the same distance per pedal stroke as a compact road bike in climbing gears. Finally, understand the nonlinear cost of weight reduction in this category. Entry-level bikes at $500 often use high-tensile steel weighing over 13 kilograms, while dropping below the 10 kilograms threshold requires $7,005 aluminum or titanium, usually pushing the price over $2,000. For multimodal commuters, every kilogram saved reduces metabolic cost during the carry phase by approximately 8%. Prioritize folded volume for trains and frame stiffness for cars.